All right. We're live everywhere, I think. Welcome to my stream. This is the second one I've done. And this is a coding challenge, a live coding challenge um, for binary search. So if you watched my last stream, you saw that I started doing coding challenges just to get better at them. Last time I did two sum. Today I'm going to be doing binary search. So if you heard of binary search, it's a common interview question or interview technique for harder problems in order to search for a particular target in a list of numbers or characters, some sort of array. It's a uh, optimal or fast or efficient search algorithm to get through a search in a big O of log n time, which is really fast compared to um, linear time, big O of n, or big O of n squared, which is like, I think, quadratic time, which is a lot slower. So let's get into it. Make sure y'all can see my screen. Everything. Okay. So, number 704 on Leetcode, binary search. Given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. You must write an algorithm in big O of log n runtime complexity. And then they have some examples here. Nums, if target is 9, 9 exists in nums, and its index is 0, 1, 2, 3, 4. And then this one, looking for 2. 2 is not in the array, so you return -1. 2 does not exist, so return -1. And then there's constraints. Got to be greater. The nums link. So nums will always have something in it, and it won't be more than 10 to the 4th power. The value and target both will be in between these ranges. All the integers and nums are unique, and it's always in ascending order. So these are some things that, like, if I was being tested over this or interviewing over this, you might not be given these. You might have to ask these yourself, which is fine. So they kind of give you a hint on Leetcode, like what you need to do here, binary search, in order to achieve big O of log n time. So like what you could do to search for this is literally, just do a loop, for loop or while loop or whatever through the array until you get to 9, and then probably a for loop so you'll have the index and then return it. But the problem is if you're looking for 12, you would have to go through this whole array, which would be big O of n time. Linear time, you'd have to go through. If this was a list of 10 to the 4th power, then it would take you that long to get all the way through it and search it. So that's where binary search comes in, which gives you logarithmic runtime complexity. And what binary search basically is you're halving your search range on iteration iteration. So when on your first pass, you would split this input into, or this array in two, and see if your target is greater than this value or lower than this value. And then if it's greater than, you would move your search to this side, and you say, okay, look at for the middle of this, is 9 greater than. You'd have to pick a number here, which you usually pick the lower one, and you say, is it equal to 9? Okay, I found it. And then if it was 0, you would come here, or if it was -1, you come here, and you would find the middle of this range, and you would say, oh, -1 is less than 0, so then you would look in this range, and then you would pick -1. So doing that like visually is a little easier than doing it in code, but I'm going to try to do it in code as well to get faster runtime. So let's get to it. I'm going to try to make this video shorter than my last one, because my last one went like 27 minutes, which for an easy problem, which is kind of a long time. So I'm gonna try to go through this one faster. Let me know if you have any questions or anything. I don't know if I'm streaming through a different type of platform this time, so I don't know if I can see your questions or not. But either way, I'm here for you. Just ask me questions in the comments or DM me or whatever. So anyway, let's start this off. I'm using JavaScript. That's my language of choice for these type of problems. So let's start it off. What we want to do, how you usually tackle binary search is that you need to look at a range, basically like a range of numbers that you're currently searching. So at the start of this, we need to search the whole thing. So our start index is 0 here. And then our end index, can't type when people are watching, nums link -1. So that gives you the actual end index, which in this case is 0, 1, 2, 3, 4, 5. So you get the start and end index. And once you have those, what you want to do is the best way I found is to do a while loop while start index is less than or equal to end index. So as you're moving the indexes around, you're changing your search range, like looking at the halves and the sub halves. Once it gets to the point where start index goes like above index, then you've basically like run out of search and you should return -1. So I'm gonna go ahead and do that. I like to go ahead and just like return my like error out case if they have one where they say like otherwise return -1. So here, how you split your search is on a pivot index. So you need to calculate the pivot index, and in this case, our pivot index, I think here, so there's 3 on this side. It's an array of 6. So since it's even, your middle is 3 and 5, and we usually take the lowest of the middle. That's just how I've always done it, but I'm sure maybe you could do it another way, but that's the easiest way I know. So to get the pivot index, it's probably different in your language, but in JavaScript, the best way to do is to find the floor of your, let me see if I remember how to do this, end index minus start index. So basically subtracting 6 or 0, 1, 2, 3, 4, 5 from 0, which will give you 5, and then divide that by 2, and I think this is minus your start index. I hope I got this right, because otherwise I'm gonna be like screwed up. But and let me see the floor. I can't remember if this is inside of here or not. Yeah, floor. Yeah, I don't remember. I'll figure it out later. If I have bugs, then I'll fix them later. But you need the pivot index, and then you need the pivot value that index is in an array. In this case, our pivot index should be 3, or sorry, our pivot index would be 2, and the value should be 3. So I want to look for pivot index. Pivot index. Sorry, it should be nums. So I have my pivot, and this should be pivot value. Pivot value. So I basically got my pivot index, which was 2, and then I found the value for 2, which is 3, which is this, if I'm just working through this example. And in here, I want to look at this pivot value to see if target is equal to the pivot value. If target is equal to the pivot value, so you say we were looking for 3, target was equal to 3, then oh, y'all can't even see that side of the screen, but anyway, if like we were looking for 3, Yeah, if we're looking for 3 and target was equal to 3, then we would want to return the pivot index because we found what we're looking for at that point. Else, if target is greater than the pivot value, then we need to move our, if target is greater, then we need to move our start index. Because the target, that means the target is greater than the middle that we found. In this case, 9 is greater than 3. So we need to move our new window, our search window, to this half of the array. So we do that by moving the start index, making it equal to the pivot value plus 1 because we don't need to include the pivot. Else, our final case is, and I won't write it out, but this is if target is less than pivot value, then we need to move the index back. We're searching in the start part of the array. We need to take the pivot value, and this is not pivot value, I'm sorry, this is the pivot index. Pivot index minus 1. And so basically that moves, that basically would search on this side of the array at that point. And then you would keep looping through and make a new pivot in your smaller subset of the array, and then you would wait until you just got to the point where the target finally equal. You would whittle things down so much to the point where the target value would equal the pivot array. And the trick to this, the why it's so fast, is because you're splitting, you're like halving your search criteria every time. So you're getting down to it at like logarithmic runtime complexity, because you're splitting your array in half instead of just searching through everything one by one. You're basically, like, if you're searching for 9 and you look at 3 and then you say, okay, well, 9 is greater than 3, so then you look at this range and you find the middle of that, then you've already found 9 in two loops. But if you went one by one, you wouldn't find 9 to like 5 iterations, if that makes sense. You can definitely look up like videos about binary search, and it kind of can like to wrap your head around it. But once you learn how to do it, it's pretty easy. The only thing I think I messed up here is probably finding the pivot index, because I can't remember. I want to say I have it right, but yeah, because I'm taking the end index minus the start index, and I'm getting the middle of that, and then I'm subtracting the start index. I want to say that I'm doing the right thing there, but we'll see. I might have to add the start index. I can't remember. But anyway, we'll see how that goes. So what you want to do after this usually is like manually test your code. So I usually put every variable I have. If I had a whiteboard or something like that, I would just write these down. But I usually put everything I have in a comment so I can just like walk through the code manually. Pivot value. I also put like whatever you're testing. So here I'm gonna do this, and then our target is 9 in this case. These are my inputs. Start index is 0, 0, 1, 2, 3, 4, 5. End index is 5. Pivot index. So just try to walk through this calculated. End index minus start index. Okay, I see where I screwed up. Okay, so this needs to be here. So I need to take the map. I need to take the floor of n index minus start index. That's 5. 5 minus 0 is 5. Divided by 2. 2.5. Take the floor of that. 2 minus start index 0. So that gives you 2. I was looking for 0, 1, 2. So that's what I'm looking for. So I think in the case when I get to the point where I'm looking at this part of the array and my index is 0, 1, 2, 3. So if my start index was 3 to 5, let's make sure this is right. I'm just kind of skipping a little bit to make sure this code is right here. 5 minus 3 is 2. And I take divided by 2 is 1. So the floor of 1 is 1 minus 3. So I think that might be wrong, because yeah, 5 minus gives me 2 divided by 2 equals 1. So that make my pivot index negative. So I think what I'm screwing up is I'm supposed to add the start index here. So that would say 5 minus 3 equals 2 divided by 2 equals 1. Floor of 1 is 1 plus 3 will give me 4. 0, 1, 2, 3, 4. And that's what I'm looking for, because I'm only looking at this half of the array at this point. So looks like we're good with that. This is why I do this like this. You know, if you're in an interview or if you're being tested over this, you know, you have to kind of do these things. That's why I'm doing this live, man. I'm sharing the problems with everybody. Like, even I get stuck on these problems that I've even done before. And that's why I'm like trying to learn in public and really, you know, get good at this, like under pressure. And this is helping me. Hope it's helping you. So anyway, just run through like this one test case so I can go ahead and get through this. So the start 0, 5 are our ends of our search range right now. Our pivot index, we just calculated it to be 2. So then it make the pivot value 3, because that's 0, 1, 2. So the value is 3. It's 3. Then we get here. It's 3 less than, or sorry, we already know that. It's 3 here. Is 3 equal to pivot value? No. Sorry, is target equal to 3? So that's 9. Is it equal to our pivot value, which is 3? No. Is target greater than pivot value? Yes, 9 is greater than 3. So we're going to go in here. We're going to move start index to be pivot value plus 1. So start index is going to be, sorry, pivot index plus 1. So start index is going to be 2 plus 1. So that's 3. And I'm going to erase these out because we're going to go through our loop over again. And we're going to come back in the loop. Is start index still less than or greater than end index? Yes, that's true. Our new pivot index, we already did it, 3 to 5, so I won't go through that again. Our pivot index is 0, 1, 2, 3, 4. Because we're only looking at this part of the array since we changed our start index. So 0, 1, 2, 3, 4. So our new pivot index is 4. The pivot value for 4 is 9. Is target 9 equal to pivot value 9? Yes. So return pivot index. Our pivot index is 4. Should we get 4 in our answer? Yes, the output is 4. So I've done this manually and I've tested that case manually. So once I've done that, I typically would try to run the code. And let's see if this works, man, on the first try. I don't know. Yeah, it worked on the first try. So what I can do also is test the other case pretty easily on Leetcode by going in here, test case, target is 2, and then I can run the code with that input. Yep, input. I needed -1 in that case. So at this point, I can submit it. All right, and see if I get a good answer. Success. Ran through all the cases. And I've done this one before. Well, man, it's almost been a year since I've done it. And the first time I done it, I didn't even get the right answer. And I did it faster than only 39%. So it really didn't, like, competing with folks, I really didn't do that good on it. Sure, people have some really good tricks to doing binary search. But I hope that helped you guys. Binary search, you may not, like, you might get asked to do this in an interview or something, or maybe you need to do this in your coding. Like, this would be something, if you're searching for a number, instead of just looping through all the numbers, you know, you can use binary search to make your algorithm more performant and more efficient, especially when the number size n gets very large, like the size of this array. Hope this helps. Like, if you know, this is one of the foundation building blocks I'm learning to more complicated problems with binary search. Like, there'll be problems where they'll kind of ask, find the, like, the array might be rotated or something, and so you still need to find the lowest value in the array, even though it's supposed to be sorted, but it's like rotated by one index or something. And so you still need to use binary search to kind of find that wall at which the rotation has happened. So hopefully this helps. I'm going to end the stream here. Hope this helps somebody. I don't know if anybody's watching, but I'm going to post this video again. Thanks for watching. Let me know what videos I can do in the future going live. And appreciate you guys. I'm going to figure out how to end.